This tutorial will show you how to make a bicycle sprocket. This is designed to go onto a fixed gear hub. Basic configuration has 15 teeth around the perimeter, a threaded hole with a 1.37 by 24 teeth per inch thread, a recessed face, and a hub which adds some thickness to the sprocket and allows for more threads to be added. You will start by making a 15-tooth sprocket, but then you will go on to make some additional configurations so that you can make 16 teeth, 17 teeth, and 18 teeth. Although the shapes of these teeth might look fairly convincing, I would not rely upon the dimensions given in the starter file to make a real live sprocket. So this is more for looks than anything else. The starter file consists of a sketch which determines what the shape of a single tooth is, a sketch on the side plane that determines what the side profile of the sprocket and the hub is, in addition to the recessed face. Finally, a sketch which determines the shape of the teeth that are going to be cut into the hole passing through the hub. The starter file only starts out with one configuration state, which has been set for a 15-tooth sprocket. The example file has a layout sketch which is left over from an older file which is completely unnecessary, called spline layout. You may delete this. So rolling back to the first feature, what we are going to make is a little pie wedge that consists of one sector of the main face of the sprocket and one tooth. Another way to do this would be to draw first the round face of the sprocket, then in a separate configuration add the tooth, and then later on go and pattern the tooth. This method, by including this pie piece in with the tooth, saves us one step. So rolling back in front of this and turning on our sketches, what we want to do is take our layout sketch for the tooth and copy the appropriate lines to create the pie wedge. You see that the layout sketch has quite a lot going on in it. I'll go ahead and edit this. This consists of two circles 12.7 millimeters apart, which is 1/2 inch. These represent the rollers on the chain that engages the teeth. Then I've drawn some angles for the teeth and a radius rolling it off. Again, these are made up dimensions. And this, you'll often find this going on in layout sketches where you have a lot of extra stuff going on that's necessary to calculate the positions of everything. And later on, when you copy the elements into a new sketch for making an extrusion, you often are just going to be copying the pieces you need and trimming away any excess bits that you don't need. In order for this to work properly for a 15-tooth sprocket, the angle of this pie wedge has to be 360 degrees divided by 15, which is 24 degrees. Later on, when we change configurations, this angle is going to have to change, which will also make the size of this circle bigger at the same time. For the moment, we don't have to change anything. Starting a sketch on the front plane, I'm going to copy these elements and trim away the unnecessary material. Using convert entities, we also need to get this arc out here. We also need to get this pie wedge. Let's hide all types so we can see what that looks like. Now we'll trim away what we don't need. We want to keep these bits here. Now we see what has happened is, for some reason, we've lost our relation on these two curves, but we don't need to panic. Short sketches again. We'll just reestablish a relation between this curve and this curve and this sketch element here. So pre-selecting, I'll hold down my control key, co-radial, and again, control, select these two, co-radial. I'm not sure what caused the problem, but I'm not going to worry about it. So we have a sketch that's ready to go for extruding. We need to extrude it both in this direction and this direction to create the material for the tooth face. So that's going to be a two-direction extrusion. We're going to go up to vertex. We'll pick this vertex down here. In direction 2, up to vertex, and we'll pick this vertex here. The next step is to make a rotary pattern of this pie piece. Using circular pattern, we're going to pattern this around axis 1. The feature we're going to pattern is our tooth we just created. What we need to do is make a total of 15 copies. So we'll just change this to 15, and this will occur in a 360-degree arc, equal spacing, and we have our total flat sprocket with all 15 teeth. The teeth have a taper to the ends of them so that they can engage the chain more easily. To do that, we're going to be using this profile in the side layout sketch in a rotary cut to get rid of this excess material on both sides to give us this taper. So I'll roll that back. And on the right plane, draw a new sketch. Copy this line and this line using convert entities. Now all we need to do is draw some extra lines to complete these two as two-dimensional zones. So I'll just simply draw a line out here, a line down here, going across, one out here, one out here, one there. The locations of these lines is not too important as long as they are outboard of the tooth and not inboard somewhere. So now all we have to do is draw a center line passing through our origin. This time we're going to do a revolve cut, which will get rid of that material on the front and the back of the tooth, leaving this tangent line here. Next step is to add a hub to the back face, which is very simple. Turn on our sketches. From our side layout, we want to copy these lines and then revolve the hub around the axis. So on the right plane, new sketch, I'm going to copy this line. There should be another line down here. Here we are. And we see we need to just trim this excess away so that this is an enclosed 2D area. And now I can go ahead and revolve that and tell it to use this line to revolve around. That line sits on axis 1. Rolling forward a moment, we're going to be adding a slight recess to the face and the hole that passes through the hub that will later on have screw threads added to it. What we are going to do is make the hole smaller than necessary so that we have material to cut our threads into later on. And this will be a little more clear as I go through the process. First I'll back up to show how this recess and this hole are made. On the right plane, we make a new sketch. we're going to copy this line and this line to revolve the front face recess. And this triangular profile here represents what one tooth looks like of the threaded hole. The threaded hole, the maximum diameter is at the tip of the tooth and the minimum diameter is down at the base of the tooth. We are going to make our hole, when we first cut it through with this revolve, have the size of the base of the tooth so that when we cut our teeth in, we will have this material here to cut into. I'll just demonstrate and hope that this makes it clear. So using convert entities, copy this line, and instead of copying this line, I'm going to copy this one. Should also have another line here I need to copy. And finally, one on this face. So I'm going to stretch this line out. Should have one more line here and one more line here, so let me go ahead and add those. I'm going to stretch this line this way. Now I'm going to trim, getting rid of this piece, this here, here, and this excess down here. So this portion here is going to create the recess when we revolve it, and this portion here will create the through hole when we revolve it. I'm going to revolve cut, pick that as our axis. So now you see we've gotten two features for one, this recess here and our through hole. The next step is to cut our first screw thread into the surface of the hole. A real screw thread, of course, is a single thread that's cut as a helix all the way from the beginning to the end. We are making a simplified representation of our threads by making one revolved thread tooth and then just patterning it, which takes a lot less processing power for SolidWorks. Again, going on our right plane, we're going to take this profile, revolve it around this axis to cut a single thread in the hole. It's right plane, new sketch, copy these three lines, and draw a center line from our origin that runs along axis 1. Now we can go ahead to a revolve cut. We're cutting a triangular wedge out of the surface of our hole. I had that wedge straddling one half on the outside and one half to the inside, so at the moment it looks just like a chamfer. The last step then is to take that wedge-shaped rotary cut and pattern it in this direction along axis 1. That will give us our full set of threads in the hole. Using linear pattern, I'm going to choose axis 1 as the direction of our pattern, and the feature we are going to pattern is this revolve cut for the thread we just made. Then the question is, what should the distance be between the threads? We want to have 24 threads per inch. That means the spacing between each thread is going to be 1 inch divided by 24. The trouble is we can see that the model we are working on is in millimeters.